Good evening. You've made it to 7 o'clock on the first day. Impressive. My name is Michael Kavka. We're going to be talking about Defender Advanced Threat Hunting. It is a section inside of the Defender portal that is very powerful, and there's some neat things that you could do with it that are security related that you might not think you would need normally. So the agenda is this. I'll give you a brief summary of who I am. We're going to go over what advanced hunting and KQL are. We're going to go through basic KQL structure and setup. Then we'll get into missing software, network connections, and the future being you. So who is Shecky? That would be me. For those of you that don't know, I'm a senior security engineer. I've had over 25 years experience in the IT field, including the last 7, 8 years working specifically as a security engineer for different companies. I'm a trainiac. What is a trainiac? I'm into model trains and toy trains. I've got almost every single scale of toy train available out there right now in my house. I think I'm missing 2. Feel free to come up and ask me about them at some point in time. Some of them are over 100 years old. I'm a family man. I have a wife, I have a son, and they come before just about everything else in this world for me. Contact info for me, email. I'm on the Twitters still. I'm on the InfoSec Exchange Mastodon. There's my website, which I blog on rather infrequently, and my GitHub, which some of the KQL queries that I've written are posted up there for other people to use and abuse to their likings. Let's get into the meat of it. What is Defender Advanced Hunting and KQL? We all know about Microsoft Defender for Endpoint. We've all heard of the Defender schemes and Defender for this and Defender for that. Defender Advanced Hunting is basically a way to go ahead and query the database back end of it all. It gets its telemetry in there from all the different Defender options that you have subscribed to. So if you're just Defender for Endpoint, you're only going to get the stuff that Defender for Endpoint would see. If you've got Defender for Office, you'll have that data in there also. You can have endpoint in there. You can even have network and identity information in there, and it's all kept inside of a beautiful little database that you're able to query. The amount of data in there rivals Sysmon. It is not a replacement for Sysmon, but it rivals it because it's working at that sort of level. Olaf Hartung, I can never pronounce his last name, went ahead and did a beautiful little article that compares the two and shows where Sysmon is lacking and Defender picks up the slack and vice versa. And I highly recommend it. I will be making these slides available through my GitHub page probably late next week. Everything's stored in a back-end database. KQL stands for Kusto Query Language. It's basically a database query language like you would have with SQL, et cetera. Where does the name Kusto come from is the big question that I have had for the last few years. Kusto actually wound up being the internal database name that Microsoft uses for all that data. And knowing that, it goes, okay, well, what does Kusto mean? Damned if I know. I searched. I couldn't find a real reason for the name Kusto in anything. But KQL, and don't confuse this with Kibana query language, which is also KQL, because we need to go ahead and use acronyms that are already used by 30 other different things. That is the query language. It is structured, as you will soon see, in such a way that it is different than some of the others, but if you understand like SQL languages or Splunk queries, et cetera, you can go ahead and figure out where your changes need to be and how to structure it properly. What you have up here on the screen, and I don't know if you can see that, the big section there, that's your actual KQL, new query, completely blank, as you see it inside of the Defender portal. This goes ahead and allows you different things on the, as you're looking at it, well, I'm looking at it. On the left-hand side, you'll see a section, and we'll blow that up for you in a bit, but that's a schema section. That'll tell you what the top-end table is for each individual item that you can do, and you will be able to expand those out. On the bottom part of the screen is a very basic KQL query that I wrote to detect who am I, and we'll go over that shortly. Here you can see the advanced hunting. I expanded out, and it might be because of the size, it might be tough to see, but I expanded out, device file events, which includes timestamp, device ID, all the different pieces of data. When creating a KQL query, the first thing that I usually do is I'll take the top table, and I'll just run it for a 24-hour period or a very short period, just to see how it lays out what it returns. And the reasoning behind that is you can go ahead and find out what you need to go ahead and focus on and what sort of data comes back. And what sort of data comes back in a number of cases is true-false. Or you might be getting an actual JSON back as an additional fields. So in yellow here, we've got the basic query. First thing that you see is you see your table name, device process events in this case. There's also things like device events, identity, just about everything has a table name in it. Then you get into your qualifiers, which are preceded by the pipes. Where is the most common thing that you will use throughout a query, especially a basic query? The where statement is followed by something by the data name, and then equals, contains, or you could put an exclamation mark in front of it and go ahead and say does not contain, which comes in very handy. The contains I find to be one of the most useful systems ever because you don't want to type everything out, or you're searching for something specifically that you know that these three unique letters that aren't going to show up in just about anything else are going to be in there, and whatever's in front and back, such as computer names, depending upon your computer naming scheme. You have your and ors, so I could go ahead with the where file name contains who am I could amend that with and file name contains, or file name does not contain, and string them together to make things tightened up a bit more. There's multiple wheres to go ahead and tighten things up. You'll see I've got a where file name, and then I've got a where initiating process file name. Skype uses who am I to go ahead and decide if it can upgrade itself. There are a lot of programs that do scary stuff like that. Your output, most of the time, I just use a straight project. You can go ahead and select whatever pieces of data that you want once you know what you're looking for. So if I don't want to have this table or this because that's not relevant to what I'm searching for, I can go ahead and cut it out completely and just put down device name and file name and username and just have that come out and do a table for me. And you don't see it in here, but there is a way to make comments. They can go just about anywhere. Usually you will see them either in their own line or right after a where statement to go ahead and explain everything out, and it's done with the double, is that the forward slash? I always get forward and backslash mixed up. Advanced items inside of it, you can use variables, and we'll see an example of that coming up. You can use if statements. You can go ahead and create a distinct output based on the piece of data that you're looking for. I tend to do it quite often with device name. So that way I'm looking at individual computers that it's very distinct data on there, so that way I'm not getting 10,000 rows, and 10,000 rows is the ultimate output that you can get. It will not give you more than 10,000 rows of output. You can go ahead and create a summarized set. And we'll see what that is, and I'll explain it more once we get to that. And you can go ahead and put output, project output, based on whether something is or is not inside of that summarized set. And we're going to see that very shortly here. So there's a lot of power behind it and a lot of customization that you can do with a KQL query. Finally, you can join multiple tables. So if you've got device process events, device network events, and identity all together, you can go ahead and start off with device process events is this, and device events is this, it joined this. And we'll get into the join, but you can do that multiple ways, so that way you could really narrow your focus down. And knowing tactics, techniques, and procedures, if you know those, you could really start getting into some, Kathy, who's sitting up here in front, was talking about this during her talk. You can really get into some real cool stuff that'll frustrate red teams when they're working in. So, software queries. Why would I want to query for a piece of software? True story. In the last year, I went ahead and was asked, because our infra team could not figure it out, what machines were missing our Qualys agent. That's rather important to keep yourself going with your vulnerability system if your vulnerability agent isn't on there. Well, sure, it's going to go ahead and scan anyways, but you're not going to get the extreme details. So I sat there and I said, let's see what I can do. And the TVM table, which is their threat and vulnerability management table, allows me to look at software. So what we've got here is the first line, you've got device TVM software inventory. So I'm taking a look at the inventory of the software on all the machines. Then I'm going ahead and I'm looking where the device name contains. In this case, we have some VDIs out there, and we don't want to include the VDIs, because that's a whole separate thing that's all brought off of master images. I'm not looking for anything that has a server operating system, so I've got the OS platform line there not containing server inside of it. That way I'm not having to type out server 2010, server 2019, server 2022, server bite my butt. I'm not looking for Linux. We're not putting the agent on Linux machines, and we don't have a lot of Linux machines anyways. So I backed that out. That way I started getting more and more down to the desktop, laptop level. Then I went ahead and said summarize, which summarizes summarize. If you don't know what that word is, well, there's a thing called Google. We can look that up. All software installed is a variable. And it equals making a set of the software names that are inside of the TVM software inventory, and it's being done per device name. So it'll give me the device name and a grouping of all the software that's on that machine. The final line is where the set has the element all software installed, Qualys Cloud Security Agent equals 0. Now this is, remember when I said you go ahead and you do your initial table and just do a quick output on it? This will show you in a case like this, Qualys, it would give you a 0 or a 1, depending upon, or nothing, depending upon whether it was true or false that it had it. In this case, I'm looking for everything that has a hard 0 on it, which means that it does not have this piece of software that's inside of this set of software that's on this machine. And then it's going to output all the machine names that are missing this piece of software into a nice little table. When I ran this, I came up with actual 6 machines inside of my network that didn't have this software. And mind you, we've got things like manage engine software and stuff like that that's supposed to do all this inventory, and they should be able to get this stuff out. This query took me about an hour and a half to write. Not a lot of time if you really think about it. Now going forward, I can change out that Qualys security agent over to Fortinet VPN, Cisco VPN, whatever piece of software. Ask Toolbar. There's one you haven't heard for a while. Do I want to see if anybody has Ask Toolbar installed onto it? Change it over to Ask Toolbar, put it equals 1, and I'd get a listing of machines that have that old Ask Toolbar sitting on it. So for security, that is rather important, knowing what is and what is not on a machine, because that gives you a better idea of what your threat area is, what your threat surface is, and if all the proper security software is in place. Now, just for kicks, just so you understand, KQL is not limited to Defender. It is used in Microsoft's Graph. It is used in Log Analytics inside of Azure. It is used inside of Sentinel. Tables are different. For instance, in Azure, that's the exact same query minus some of the tightening on it, because all that it was looking at was Azure joined laptops, so I wouldn't see any on-prem. But it's the exact same query. You'll notice that the initial table is app inventory underscore CL. You'll notice that the make set is app name underscore S. So you would think that Microsoft would have a way for you to know what is equivalent. No, you get to figure it out yourself. Just to make things more interesting. So here we have a simple query. Very possibly one of the neatest ones I've got, outside of that who am I query. I've caught almost every single red team that's gone against us on that who am I query. The next one I want to go over with you, as we're winding down here, is the remote desktop connection query. Port 3389. Who here loves port 3389? You know, it has to be open for some odd reason because of Active Directory, right? What we don't want to see is people going ahead and remoting into machines. We don't want to see that RDP itself going. You know, you can figure that out through Defender Advanced Query. And there's the actual query. And this, I do believe I have this one up in my GitHub right now. This one has a join in it. It is a much more advanced type of query. So what I started off doing was I only wanted to look at the past week. So the first line is timestamp ago 7 days. Then I went ahead and I did for the network events where the connection is a success. So it actually connects. Make sure that it's connecting only on port 3389. Make sure that the process is mstsc.exe. Anybody know what that is? Remote desktop connection. You'll see a commented outline where local admin not equals 1. That is a line there for me to remember in case I want to look for local admins only or what have not. Yes, local admins, no local admins. In this case, I didn't care if it was a local admin or not. I wanted it. But I put that in there for future consideration. Then you'll see also join device login events on device name. So what that's doing is that's saying, okay, we've got these device network events. Now we're going to take these login events and look at device name as the same thing on both of them, and we can go forward from there. So now I'm locking in the network events device, the devices in the network events table over to the login events table. Then there's a couple of contains or not contains. I killed off our service account names because they're going to do their own thing and they're not going to be an interactive connection properly. I took off our SCCM server because that one will go ahead and hit 3389 and get shown up in everything. I got rid of computer account names because you're not going to be you're not looking for people that have, you're not looking for a computer, you're looking for an actual individual. And computer account names still actually use 3389. Then I said where it's not equal to system, Active Directory. Finally, I said where it contains an interactive login, thanks to Active Directory for not doing an interactive login. So that way I could go ahead and say, yes, this is a person that's actually connecting and logging in and physically doing something onto that machine. Then you'll see two separate things down here at the bottom. There's a summarize by device name. And I picked out what data points I wanted out there, including the account name that's doing it, what remote port they're actually hitting, so that way I could show that they're hitting 3389, what the initiating process file name is. Are they doing it from command line? Are they just using the graphic interface? Devs use the command line. Below that, you'll see just a straight project. That gave me like 4 times as much data. But there is instances where you might want to do that. I have the summary there as my main, but when I'm trying to go through and make sure that I'm not missing anything, I'll uncomment out the project and I'll comment out the summarize. So that way I can just flip between them. And now I don't have to have 2 queries sitting there. I've got one query where I just make a slight adjustment to the query itself for my own sanity's sake, because I'm old. Potential troubles that you can run into with this. Now, I mentioned about Sentinel and stuff like that, and you go, well, why can't you just dump all this stuff into your SIM? Well, pulling data from Defender into a SIM is hard. Most of the APIs don't give you the full amount of data that you're going to get when you actually punch in a KQL query into Defender's KQL section itself. Even when you go, well, what about Sentinel? I go, ingesting the data, all that extra data into Sentinel costs money. You get free ingestion of the alerts, but you want the actual back-end data to be able to query on? Nope, sorry, you got to pay for that. Queries in Defender itself only go back 30 days worth of data. That's the biggest catch. There are a lot of people out there. That's why you can't use it as a true SIM, because a lot of places you need to have that data going back 120 days or further in a lot of instances, some cases 7 years even, depending upon your industry and regulation requirements. But it does work as far as a quick thing goes. And then you can go ahead and prove that, yeah, we need to get this data into our SIM or into Sentinel where we can have it for a year, 2 years to go back through. Data from the endpoint can take 20 minutes to see in Defender. This is by design. Microsoft went ahead and decided, I was talking with an engineer last year, they made a decision that they didn't want to slow down machines, so for performance issues, it only makes a callback once every 20 minutes. And I've yet to figure out how to tell when that 20-minute time period is up. So when I've run it 1 minute, and then 2 minutes later, all of a sudden, boom, I've hit that 20-minute time period, which I didn't even realize. So it's not instantaneous. It's not live data. It's literally, it can be up to 20 minutes late. For real advanced items, you'd have to go through JSON. There's an advanced field. Most of that winds up looking like a JSON table. Parsing through that can get very complex. Not everything that Defender Agent sees is available. I'd had a great idea of going ahead and being able to search for specific things that would be specific API calls, Windows API calls, that are used to go ahead and unhook Defender itself, et cetera. And when I was talking with Microsoft, they were like, yeah, most people don't want that data, and we need to keep our stuff compact. So not everything that the agent sees is actually transmitted on up. API usage can get goofy. You're dealing with JSONs, you have to work into specific tables, you have to know exactly how your query is called inside of everything like that. Luckily, they've got an API Explorer, which should allow you to figure that stuff out. Finally, many new features for Defender that they are coming out with are now a la carte. E5 is everything. No more. Most of the newest stuff they're doing, even if you've got E5, you have to pay a la carte prices on a bunch of it, which means, of course, that you're going to have some blind spots. I've included, for those of you that want to go ahead and download, a couple of links. One of them is a thing called Must Learn KQL. It's been put out by Rod Trent, fantastic Microsoft guy. It is a fantastic course on how to use KQL properly. Defender Ninja training will go into that and all the deep dive of what you can do with Defender. Again, that's put out by Microsoft. And Microsoft actually has a GitHub of a KQL repository. Some of the stuff there is old. Some of it you're going to have to figure out how to recreate a little bit and what's not working, what it's changed to. But it is a very solid repository. Finally, to recap, advanced hunting query for KQL can be very powerful. The data inside of Defender is very fruitful. There's a lot more in there than what you would see out of the box. Looking for things like RDP and software can enhance your security. And finally, you can create custom detections from the queries provided. And by that, you have to include 3 tables when you project. 3 items, a device ID, a report ID, and a timestamp. Without those 3, it will say, sorry, you're missing one of these 3. We will not create this detection for you to alert on. But if you put those into the project output, you can go ahead and create any sort of alert that you want. Talk about making hell for the red team. Thank you very much for coming. I hope that you learned something, and we'll see you around. Feel free to come up to me during the course of the conference.